In real formulation adjustments, one of the most common and most time-wasting habits is to immediately focus on whether a certain catalyst should be added and how much of it should be used. In this episode, we are not talking about specific numbers. We are only clarifying the direction first. In flexible foam systems, catalyst formulation design is not essentially a problem of numerical optimization. It is a problem of structural judgment. If your attention is fixed on dosage from the very beginning, it usually means that the most important judgment step has already been skipped. The first thing you must determine is whether the system is currently lacking foaming space or gel support. This is the true starting point of formulation design, not something to consider later. In lower density products that emphasize softness or resilience, the system often relies more heavily on the rhythm of gas generation. If the foaming reaction is suppressed too much in this case, the foam may still form, but it often feels dull and lacks rebound. In contrast, in higher density products or applications with higher structural requirements, the importance of gelation is significantly amplified. If the skeleton cannot establish itself in time, even good foaming conditions cannot support the final structure. Only after this first judgment is clear do the respective roles of amine and tin catalysts become meaningful. Otherwise, what looks like fine-tuning is actually repeated trial and error built on a wrong premise. The second step is to judge how wide the processing window really is. Some formulations are very tolerant. Small variations in temperature, metering, or raw material quality do not immediately turn into defects. Other systems operate within a very narrow window, where even slight changes in reaction rhythm quickly show up as collapse, closed cells, or structural instability. If a system with a narrow window is still treated with a fast reaction mindset, the adjustment space only becomes smaller. In these cases, the real solution is often not adding more catalyst, but re-examining the reaction rhythm itself. Only in the third step does it make sense to fine-tune actual dosage. In mature formulation design, catalysts are never viewed in isolation, but as part of an overall reaction balance. Foaming, gelation, flowability, and curing time are always linked, with trade-offs between them. Truly stable and repeatable formulations are rarely the ones with the fastest reactions. They are the ones that do not immediately lose control when on-site conditions change slightly. A healthy adjustment sequence is always the same. First determine the direction, then confirm the processing window, and only then adjust dosage. If this order is reversed, the more you adjust, the more chaotic the results tend to become. Once the direction is clear, the numbers usually turn out to be much less difficult than they initially seem.